The final permutation notation we need to talk about in order to discuss the Futurama theorem is called cycle notation. And cycle notation really is following a path through two-row notation. Two-row notation is the easier one to convert to cycle notation. So the first thing I'm going to do is think about going from two-row notation, like this permutation, into cycle notation, whatever that means. And to do that, I'm going to think about it in terms of, really, I'm starting to think about it more like functions, mathematical functions. But if that makes you uncomfortable, you don't have to think about it as a function. Just think about the 1, the first position is a 4. So first is the 4, or how I read it is 1 goes to 4. So I'm going to start at 1. So I start a cycle with an open parentheses. I'm going to start at the number 1, and I look at what's below 1 in two-row notation. 1 goes to 4, or in the first position, I have a 4. And it's a cycle because I'm going to keep reading it in that way. Look at the number, see what's below it in two-row notation. I'm going to keep reading it like that until I get back to where I started, and that completes the cycle. So I went from 1 to 4. Now I'm at 4. 4 goes to 1, which is where I started. So that's actually where I end my cycle. So I put in the end parenthesis there. But I'm not done because I haven't looked at all of the numbers. So I've looked at 1 and 4, but I haven't looked at 2 and 3 yet. So I need to look at what happens, say, to 2. So I'll start the next cycle at 2. Well, where does 2 go? Below the 2 in two-row notation is a 3, so 2 goes to 3. And then where does 3 go? Back to 2, which is where my cycle started. So I end my cycle. And since that's all of the numbers in this permutation, that's all of the cycles. The cycle 1, 4, and the cycle 2, 3. Looking at another example, I'll start at 1 again. It doesn't actually matter at all where you start, but I typically start at 1. So we look at the cycle that starts at 1. Well, 1 goes to 2. What happens to 2? I look at what's below 2 in the two-row notation. 2 goes to 5. So 5 comes next in that cycle. What happens to the 5? Well, below the 5 in two-row notation, I have the 4. So 4 comes next in this cycle. And then where does the 4 go? Below the 4 in two-row notation, I have the 3. So the 4 goes to 3. And then what happens to the 3? It goes to 1, which is where we started. So that's the end of my cycle. And since that's all the numbers I have, 1, 2, 3, 4, 5, that's the end of my cycle notation. So our first example had 4 numbers, but it broke into 2 different cycles. Our second example had 5 numbers, but it was all one cycle. 1 goes to 2, 2 goes to 5, 5 goes to 4, 4 goes to 3, 3 goes back to 1, and that completes the cycle. All right, let's look at one more example of converting two-row notation to cycle notation. Again, I'm going to start at 1. There's no special reason I start at 1. That's just where I like to start. So I started at 1. Where does it go? To 3. That's what's below the 1 in two-row notation. So 1 goes to 3. What happens to the 3? It goes to 2. What happens to the 2? It goes to 4. What happens to the 4? It goes to 6. What happens to the 6? It goes back to 1, which is where I started. So that's the end of my cycle. But I haven't gotten all the numbers yet. I need 1, 2, 3, 4, 5, 6, and I only have 5 of those numbers. So there must be another cycle. Let's see. 5 isn't used yet, so let's start at 5. Well, where does 5 go? Oh, it goes back to 5. That's where I started. So it's its own cycle. 5 stays at 5. Might be a way to think about that. So here we have 2 cycles, but one of them only has 1 number in it. 5 always goes to 5. So here are a couple of examples of going from cycle notation, or from to row notation to cycle notation. We can go the other way. So if I think about this permutation, which is in cycle notation, I see the numbers 1 through 8. And so I know the 2-row notation will have the numbers 1 through 8 in order in the top row. That's how 2-row notation works. It always has the numbers in order across the top. And then it will have sort of the reordering in the bottom row. Or when we think about cycle notation, we think about this sort of goes to relationship. So 1 goes to 4. If I read this cycle notation correctly, 1 goes to 4. Well, that means 4 must have been below the 1 in 2-row notation, so I can fill that in. 4 goes to 3, so below that 4, I must have had a 3. And then 3 is at the end of the cycle, which means it must go back to 1. So underneath the 3 in 2-row notation, I must have had a 1. If I look at 2, it goes to 5, so I could fill in the 5 below the 2 in 2-row notation. 5 goes to 8, so I fill in the 8 below the 5 in 2-row notation. And the 8 goes back to 2 because it's the end of the cycle, so the 8 will go back to the beginning. I would fill in a 2 below the 8. And then our last 2 spots to fill in, 6 goes to 7, so the 7 should go below the 6. And 7 is at the end of the cycle, so it goes back to the beginning at 6. So this is our 2-line notation for the same permutation which was given in cycle notation originally.